Hi guys, I hope it's going well. This is our first lesson for Unit 6, and this lesson is about some of the one variable statistics that you can do in this course at least. There's lots more beyond this, but this is kind of an introduction to some of the basic stuff that you would use to analyze a data set or to describe a data set. So probably the most common stat used out there would be to describe things by the average. We always want to compare things, to what's the normal, if you want to call it that, or the average value. And so if you have numbers associated with your data set so that they're qualitative or quantitative, then you can often find one, two, or three different ways of getting the average. And that's what's called the central tendency. The most common one that most people think of when you say average is what's called the mean. And you might have learned this probably in the past. Probably in grade 7 would be the last time you do this in stats. But remember, the mean is just really you take all the sum of all of your data points and divide them by the total number of data points. So the sum of all the values in a set of data. And then we divide by the number of data points. So most people, if they say, my average is this is the kind of average they're referring to, but really the average could be two other ones that we're going to talk about, the median and the mode as well. So there's a couple of formulas here down below. They're really actually the same formula, but you'll notice that there's two different variables here listed that they're equal to. And one represents the population and the other a sample of a population. Remember before we talked about we often don't, take a sample of the whole population. We don't do a census because it's just too challenging and expensive and logistically difficult. And so in stats, you often are taking samples, and there's a whole ton of analysis that goes on with this. And so to distinguish between the two, we have two different symbols to represent them. And so if it's a population mean, it gets this U with this long stick on the front, which is called mu. I remember we laughed at that in high school. And this one is called X bar. And X bar is the one that you're probably going to see and use most of the time because it's not too often that you have a whole population. And it's not always clear if it's the population or not. So we're just going to use X bar as the notation. But I will warn you, when you go on in stats, there's just so much notation, it becomes challenging. For example, rather than write out this whole formula where you're adding up all of the x's all the way to the nth x point, what you can use is something that's a bit more concise. Some of you may have seen this. This is capital letter sigma. And what it means is the sum of. And I'm a bit surprised it's not included like in grade 11 functions to use this when you're summing up, arithmetic or geometric sequences, but they don't anymore. But basically this is a lazy way of writing out, this is going to be the sum of all of my x values divided by n. So it allows you to more succinctly write what you'd like to in terms of when you're adding things together. And when you do, I think if you use the sum of formula on Excel, you'll see that sigma pop up. Anyway, little extra information. So let's try an example here. It says the school would like to know the mean time student spends on sports in a week. So they're specific here about their average. They're saying the mean time. They surveyed 20 students. So we know that it's going to be a sample. So we've got this data set arranged. We've got 20 of them. So rather than write out everything, what I'm going to do is I've got my sample mean x bar is going to be the sum of all of my x's divided by n. And what you can do is just write in a few of them. So I'll just start from the left. And then dot, 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 and then a plus, and then the last couple. And that shows that I'm taking this whole set. And we know that there's 20 students. So we plug that in, and really it's pretty easy algebraic thing to do. It's just plug numbers in. But it's also easy to make a little mistake if you forget a number or type in the wrong number. But if you do that, and you can try it if you want or wait till a practice question later, but you should get approximately 21.2. And so in this one, I'm going to round to one decimal place, but I would be specific about what I would like you to round to on a test or assessment. So this tells us information, right? It gives us something to compare. Let's say I do 10 hours of sports in a week or something like that, and the average is doing 21.2. We always like to compare. I don't know if it's the right thing to do, but it gives us a base for where things are. But we're also going to talk about if you're far away from the average, sometimes that's a good thing, and it really doesn't matter. It just gives you something to discuss or give reference to. So as I said, there's more ways to calculate the average than the mean. The next one we're going to look at is the median. I saw this meme, so I liked it. And somebody had said Keanu, such a great actor, or had a survey question about that earlier, last unit. Anyway, so the median is the middle value of a data set. And in fact, it could be more than one, and we'll talk about that in a second. And it's the middle value, not just as we see like in this example, but it's when it's arranged from lowest to highest. So you could say in ascending order, and in fact it would work also in descending order, but generally we go from lowest to highest. And so sometimes, depending on the number of data points, like the one we had above was 20, and we're going to see if there is an even number of data, the median is the midpoint between the two middle values. And so we'll talk about how to do that, which is basically calculate the mean of those two middle points. So the first thing you need to do is to organize the data into a list from smallest to largest, which can be time consuming, and pick the data value in the middle. If there are two values in the middle, determine the average of the two. So let's try that. So if this was an assessment, I would probably give you, max 5 to 7 data points to arrange in order. But this time I've given you, this is on your handout, I believe, those data points from question 1, just arranged from lowest to highest. So we have here in the top row is the rank. So from the lowest being number 1 all the way to the highest being number 20. And then in the second row, we have the value of each of them. And so most of the time you would use technology to, if you had a large data set, to arrange these from lowest to highest. Otherwise, it's just a pain in the butt. So in this case, one way to figure this out is you can always just rely, okay, what's the middle data point of 20? And some people might say, well, it's 10. Well, in fact, it's not 10. It falls directly in between 10 and 11. And a way to do that is to always take n plus 1 and divide it by 2. And that's going to give you your middle data value, or data point, I'll say. And so if I do that, I've got 20 data points plus 1 divided by 2. The middle is 10.5. And so what that tells me is that this is where I need to take two values and add them together. And so if I look at where 10 is, so 10 is here, so it's in between here. So this is my middle value, or my median. But what I need to do is to take the average of the two right beside it. And so I'm going to take the mean of those two data points. And so I have 15 plus 16, and I divide it by 2, which gives me 15.5. So 15 was the value of the 10th data point, and 16 was the value of the 11th. And so taking those two, adding them up, we get the median. So therefore, the median is 15.5. So in this case, we didn't even have a value in our data set of 15.5, but that's our median because it's the average of the two. So again, if there's an even number of data, as we wrote up here, the median is the midpoint between the two middle points, and just like that. If there's an odd, you can still use this odd number of data points. You can still use that, and it'll just give you one data point. So let's say there was a 17 data points, for example. I would take 17 plus 1 and I would divide it by 2, and that gives me 9. And so my middle data point would just be 1. So pretty easy to rely on that little formula of n plus 1 divided by 2. Okay, so you can see the mean 21.2, median quite a bit different. And you sometimes see also with the third measure, it also will be quite different. And this is one that's quite specific and only really applicable in some instances. And this is what's called the mode. And this is the value or values in a set that occurs most frequently. So a good example of that would be like, when you're looking at sizes of clothes or shoes or something like that, when you talk about the average, most people talk about like the one size that occurs the most often, and that's how people will often stock their shelves based on that. So let's say the medium is the one that occurs most often. That would be the mode. So mode is often used with not only numbers, but also with qualitative data, where you have, what eye color is the average. You wouldn't add up green and blue and divide them by 2. You would take the one that occurs most often. And so things like that where they fit into categories. So how to determine the mode? Well, you can create a frequency table if necessary to see how often things occur, which we've done in the past. And the value with the highest frequency is the mode. And there can be more than one mode. It's often capped at 2 modes. Like generally they don't like to give more than 2 modes, but it really depends on where you're reading it. So if you look at the data set from the first example, find the mode. Well, they're arranged kind of here for us. I just delete this part. I can look, and I believe, let's see, data values. 15 occurs 3 times, I believe, and also 12. And so you can see here 12 and 15 occur 3 times. So I'll just write that, 12 and 15. So they are the mode. And so pretty easy, and we'll see again later if they're ranged with a frequency table, it's even easier. So as I said, this is a way to describe data, and we're going to see a bunch of stuff that extends way beyond this in terms of distribution of data sets, and so how data is spread out outside of the average. And so when we talk about something that's a symmetrical distribution, we would say the mean, the median, and the mode will be equal. And we'll talk more about this stuff next class, but so imagine you had something like this. In this example, so this is my values. This is the number of data points on this axis. And in the middle here, you would find the mean, the median, and the mode. And so this is, you've probably seen this is a normal distribution that a lot of people call the bell curve, that we'll learn about later. And it's interesting because you can describe things by the averages and another measure of spread. And so if it's symmetrical, those things are all equal. So mean, median, mode. An outlier, and we'll talk about this in the next class as well, but an outlier is an element of the data set that significantly differs from the rest of the data points. And so we're going to make it so you could be able to definitively say, okay, that's an outlier by using stats. But for now, we're just going to try to eye them up and see if they are far away from everything else. So you can also skew. You probably heard this term, to skew the distribution, and we can skew it so that it's leaning more one way or another way, so left or right, or in this way we say positive or negative. And so you don't have to memorize this, but in a negatively skewed distribution, the mode is greater than the median, and then it's greater than the mean. And then conversely, in a positive one, it's here. What you do need to know is if you see the shape of it, whether it's positive or negatively skewed. This one on the left is positively skewed, and it's not obvious, but on the positive side of things, there's a space. That's the way I remember it. And on this one, on the negative side, on the left, there's this space. And so that tells us where it's been skewed. And if you know the mean, median, and mode, you can figure that stuff out. And so if we looked at our first example that we had from mean, median, and mode, the mean was the highest, median was next, and then the mode was the lowest. And so in this one, we had the mean greater than the median and greater than the mode. And so therefore, the data set was positively skewed. Or is positively skewed. And can you identify any outliers? Well, it's hard when you don't have it graphically, but if you look at the table, we're going from 10 all the way to 50. And if you try to look at the data, and we're going to do a better job of this next class, but if you go along, we've got 10, 12, lots of 12s, 15, 20, 30, and then all of a sudden we kind of do a jump here up to 45 and 50. And so because there's such a spread in between the 18th data point to the 19th, we can say probably that 45 and 50 are outliers. And again, we're going to find a way to do that more precisely to figure out if they are outliers later on. Okay, so a couple other things to do with the mean is that it can get a bit more complex when you have weighted means. Like for example, in your courses, for a math course, we generally weight the different categories of knowledge, thinking, communication, and application with different weights. So knowledge and application are weighted to 40%, and the other two are weighted to 10%. And so you can get weighted means on this. If you do a standardized test for certain things, or if you go in for a job interview, often they'll test you, but they might weight certain tests differently. Like personality tests might be weighted more than logical thinking or something on a test. And you'll probably encounter this at some point in your life. And so it's good to be able to calculate weighted means and understand how they work. So weighted mean is a measure of central tendency that reflects the greater significance of certain data. Like I was saying, the personality test might be weighted more than something else. So let's stick to an example like what we have in our course or in other courses. It says on the last test, Joey received the following scores, and we've got knowledge, application, communication, and thinking. The weightings for each are as follows: 40, 40, 10, 10, and calculate Joey's grade on the test. And so this is why some people get a little confused as to why, they might do better on a test, but overall their average goes down. And it's because they might have done better in a certain category that was weighted less, where they already had a good mark. And it does get a bit confusing. So in this case, if we want to calculate this weighted mean, we just take each of these, so 10 out of 28, and then we multiply it by its weighting as a decimal. So times 0.4. And this formula that's given above here is a way to kind of calculate this if there isn't a more logical way to figure it out. This one's a bit more logical. Then we take the next category, so 10 out of 12, and it's weighted again to 40%. So you can see there's a big difference here between knowledge and application, what it's out of in terms of 28 versus 12, but the weighting is the same. So that kind of messes things up a bit, and that's why we always try to stick to same values for those two. And then the next one, I know I'm writing brackets in different spots, but times 0.1, and then the last one, 8 over 12 times 0.1. Oops. And so if you do that and add them up, I think I got 43 out of 70, which gives approximately, we would want this as a percentage, 0.614. Therefore, Joey's average was, or is, 61.4%. And you'll get a couple examples like this in the practice questions to try out that are slightly different. And then there's another situation here where we've already got data. So this would be secondary data that has been, and it's not raw data, it's been collected and sorted. And so you got intervals or groups. To calculate the mean, you would need to use a weighted average where the x value is the midpoint of the intervals and the weight is the frequency. And this kind of makes sense logically. It probably makes more sense logically than that description. If we look at the question, it says, how many hours per day do children spend watching TV? So we've got categories, 0 to 1, 1 to 2. These are bad categories because they overlap, but we'll use them anyway. And here, what we want is the midpoint. Because we don't know if it was 0 or 1, it's in a range of values. We have to use a midpoint. And so when we're doing this, this is only going to be an estimation of mean, median, and mode. Because we don't know exactly what the values were. So let's put in the midpoints though. So we got 0.5, 1.5, 2.5. So I just add the two together and divide by 2 each time, or just see the trend here. And so when you read this, the number of children that watch is 1 to 2 hours is 4, 2 to 3 is 7. So you can automatically come up with the mode directly from looking at this. And so the mode is going to be the one that occurs most often. And so that's the frequency. And so your mode is going to be this occurs most often, which the value associated with that is 2.5. And so we give the midpoint as the value. And then you could also easily calculate the median before we do the mode. And this you would arrange from lowest to highest. This is nice because they're already ranged lowest to highest, 0 hours to all the way to 6 hours. But you want the middle point. And so if you think of that, so we need the total here of kids or children. So if you add these up, 1 plus 4 is 5, 7, 12, 15, plus another 3 is 18. So the median is going to be my nth. Maybe let's just do the n plus 1 divided by 2 thing. So 18 plus 1 divided by 2, which is going to give me 9.5. So it's going to be, the rank of it is going to be the 9.5 or between 9 and 10th child. And so if you go here, the cumulative frequency from here to here would be 5. And then from here to here would be another 7, which would be 12. So you know that the middle children, or the middle point that associates with the children, is going to be again in this category here of 2.5. So my median is 2.5 because not only does the 9th and 10th data point fall there, but also ones below that and above it. So that works out pretty easy. So now the mean, let's do that. In this case, what we need to do is take our midpoint times the frequency. And so we take 0.5 times 1, and then we do it for each of them. And this makes sense because what you've got is the number of times that value occurs. So I could write 0.5 once. The next one I would write 1.5, but I would write it 4 times because there's 4 children that fit there. Rather than write it 4 times, I just say times 4. And then similarly, 2.5, rather than write it 7 times, I'll just write times 7, and so on. And keep going. And then, looks like cos. And then if I take all of that, I need to divide by n, the total number of children. And that should always be the adding together of all of these guys here. So that should equal whatever I put into the denominator, which is 18, which is n. And so I'll give you a second, you can plug all that in, and what you get, if you want to try it on your own, is approximately 2.72. And so my mean is larger than the mode and median. Okay, so there's a bunch of questions here to try in the textbook. Make sure you try them all because there are some slight differences between them. Okay, let me know